In this video, I'm going to talk about stuff that we did not cover in this course, and what else could there possibly be in C#. We have covered so much stuff in this course already, and the answer is lots of stuff. Remember, C# has an 800-page specification. There are tons of language features that we have not gotten to yet. And I'm going to go through just a small number of them here just to give you some of the feel of them. And I'm just going to talk to slides. I'm not going to actually display these in Visual Studio. There are user-defined value types. We've seen how to make classes and interfaces. We did not see how to make delegates, our own delegates, but we saw how to use delegates. All of those things are reference types. But we also know that there are integers and doubles and all of these kinds of things. We know that there are enums, which are value types. C# allows you to create your own custom value types other than just enums, which are just fancy integers. They're called structs, and they have many quirks to them. Structs behave quite differently than reference types. We're not going to cover them in this course, but they're very interesting, and you can get some really nice, good performance out of structs in some scenarios. We talked very briefly about functional style programming. We've looked at procedural programming, we've looked at object-oriented programming, we've looked at event-driven programming, we looked a little bit at declarative programming. We haven't really looked at functional style programming. Functional style programming is a style in which delegates become really, really important, and you end up with what are called higher order methods. So far, all of the methods that we've seen have taken as their arguments some kind of basic data. They've taken either an integer or a string or something like that, or we've made a little bit more complicated data. Like we've said, OK, well, we're going to pass in a reference to a player. The player contains a name. The name is a string, and so on. With higher order programming, you end up making methods who take as their arguments other methods, and then those methods may take as their arguments other methods, and then they may apply those to delegates or to data structures or to whatever. And it can get quite difficult to understand what's going on in functional programming, but you can also write some very, very powerful programs that are quite succinct. And LINQ, a language integrated query, which is a feature added to C#3, whereby you can embed in your C# program, you can embed filters and grouping and joining and all kinds of other operations on data. It was very strongly influenced by functional programming. We talked a little bit about generics in this course. We talked about how to use the generic collections. We looked at some generic delegates for generic event handlers. We looked at nullables, which are a form of generic. You can define your own generic interfaces, generic classes, generic structs, generic delegates. We did not talk about that at all in this course. You can also make generic methods. It's maybe not 100% clear what it means to have a generic method. It's kind of an odd feature, but it's something you can do. Also, generics support a feature called contravariance and covariance. I mentioned return type covariance in an earlier video. Generics have yet another kind of covariance, and it's a covariance where you can say, well, if a giraffe is a kind of animal, then is a sequence of giraffes a kind of sequence of animals? And in some cases, the answer is yes, and in some cases, the answer is no. And it's rather tricky. But generic delegates and interfaces in C# can support some forms of covariance, and its opposite, contravariance. And then there's just a bunch more C# features that we have not seen and that I'm not going to talk about in detail. You can make methods that take references to variables instead of values. We saw that briefly with methods like the try_get_value method on dictionary that takes a reference to a variable, which is then filled in with the value if it exists. There are more complicated kinds of arrays in C#. There are arrays that take multiple dimensions in their indices, so not just one index into an array, but you could pass in 2 or 3 or 4 indices into an array. There are different forms of that. There's one form called a ragged array. There's another form called a rectangular array. We didn't look at any of that stuff. Asynchrony is an enormous topic. It's very hot in C# right now. Asynchrony is this idea of some operations are high latency. There is a long gap between when you ask for a piece of data to be computed and when that bit of data actually is computed. And maybe that latency is due to the distance involved. Like The information is being computed on a machine in Japan, and I'm in San Francisco, and it's going to physically take a long time to get the information back and forth over the undersea cable. Or maybe the latency is due to the fact that I'm asking for a very complicated calculation to be performed, and it's just going to take time. The idea of asynchronous code is, while we are waiting for that information to get back to us, our computer can still be chugging away and solving problems of its own. And how do we manage writing programs that can take into account the fact that we asked for something, but it may be quite some time before that comes back? This comes into play particularly with graphical user applications, particularly modern ones, where you never want to get into a situation where you press a button, and as a result of the button being pressed, some high latency operation happens, and the machine just freezes until the high latency operation is done 3 minutes later. That's really, really bad. A related topic to asynchrony is having multiple threads of control. This is one of the techniques that's used to achieve asynchrony. We've seen that there's a control point in our code, that it steps from line to line to line, and maybe it jumps around a bit when there's some exception handling, but there's only ever one of them. It's actually possible in C# to have programs that have arbitrarily many different threads of control all running around in the same program, and boy, does it get confusing. There are many techniques that you need to do to make programs that are multi-threaded work correctly, and that is really for advanced players only. We talked very briefly about code that reflects on other code using the assembly object and the type object, where you can say, hey, you, give me your type. Give me the assembly that you were defined in. Give me the other types in that assembly. And that's useful for building certain kinds of tools. We saw that there was a test tool, the unit testing tool, that looks for types that have a particular attribute on them and says, oh, I think this method is a test. I'm going to run this test now. And that's just one example of the kind of thing you can do with reflective code. We haven't talked about dynamic dispatch. C# usually has a feature whereby you can say, I would like to call a method foo on this method bar. And the runtime will figure out, oh, well, it looks like foo is virtual. I'm going to call the method that is on the most derived type. That's kind of a form of dynamic dispatch. We're figuring out at runtime which method to call amongst a bunch of possible methods. C# has a dynamic feature that was added in version 4 that really puts that on steroids, that really makes all of the decisions that the compiler is going to make about which methods to call deferred until runtime. It's kind of a neat little feature. And it's really used most for interoperating with languages like JavaScript that were designed around this whole idea of dynamic dispatch. C# has a feature called unsafe code. As the name implies, it turns off the safety system that is keeping you type safe and allows you direct access to the memory of the machine. It is super, super dangerous, but there are some rare situations in which you need to do that, either to interoperate with some existing code or because you need to meet a particular performance goal and the safety system is keeping you from meeting that goal. And that also is for really advanced players only. And there's a bunch more. I have not talked about nearly all of the features of C#. There's just really a ton of them. It's a fascinating language. So thank you so much for watching this long series of videos. I really enjoyed making it. If you want to email me with questions about this course or suggestions or constructive criticisms, please do. I'm at eric@lippert.com. If you like what you saw here and you want to get more, I write a blog about programming language design at ericlippert.com. And if you have specific questions about actual code that you're writing, maybe don't send those directly to me. Post those on Stack Overflow. And there are lots and lots of people on Stack Overflow who would be happy to help you. But please do try to make it a specific question about actual code. So thank you so much, and we'll see you on the internet.